Oh, what is my life? Jeez. Okay. So, I've got like quite a bit to do. Still haven't figured out the programming side, which that's okay. But we need to get uh, the mount file so here we are back in space. Nothing. Okay. So maybe we don't need to work here. Just need to build a base. Do we need the base for the base? Just work bolts. I want to get drop the bolt. I need the base. Yeah, all the stuff. So this was originally once solid, and I had to change my design. Like, oh, it just wasn't pleased with the overall quality. So, yeah, basically, like what hours of like routing done. So yeah, that was a waste of time. But got more knowledge and got better at CNC. Um, not to waste material. Disappointed, but we learn lots. Okay. Also, we need to install longer bolts because we install longer bolts because our design is getting thick. But I think for now, we'll just use the shorter bolts. So this is the base. So splinter my Okay, Jesus. Well, look at them. Okay, so we're back in. We're back. It's a long time for you. I'm getting used to this 3 a.m. Uh, yeah, I'm sorry. Yeah, I had today's a special day because today's a special day because I don't know where you work, but where I work, get these get these like cool. We get these days off. We get like 1 day off a month, and it doesn't count towards any. So long as we, so it sort of like works on a time system. So if we choose to work like the standard 40 hours, in Australia it's like 38, half an hour for lunch. So standard working week in Australia is 38.5, but if we choose to work um, 40 hours, that's basically an extra 30 minutes each day. We can use it to build up towards the time in blue month. So what this means is we can basically like choose 1 day a month to take a day off, and choosing to take like a day because tomorrow is Australia Day, and um, because tomorrow's Australia Day, and so by taking a day off strategically Monday, we have 4 day long. So I have like I'm on all day today. Um, I am super behind on this build. I spent so much money and time getting this together. So spent so much time and money getting this together, and it seems like a shame to not finish. So I'm pulling in overtime. So in short, I'm taking time off, taking time off so that I can take overtime. So it's just it's just a sequence of things never stop working. So yeah, that's the short of it. So taking time off to work on it. It's actually due midnight tonight. So we're going to be here in the shop all day trying to get this done. So yeah, I'm glad that not be the time is it over there where you are? I'm glad you can join me, Red Dragon. Right. So plan is that we are going to use. So we made the mistake of cutting the entire ring by ourselves. So we asked the LA Cutter to recut it to like small little slabs instead. What this means is that we have to assemble it. So I plan to assemble it some basically. This will eventually go up. Go down again. So, some screw alignment too. So just down. We have a lot to do. So we're basically just doing an alternating link pattern. Standard overlays. Using hot glue because it's good for rapid. Although we're like really fast rapid, but ideally if I had time, I'll probably just get it. That would take too long. Just try to get this across the line as fast as we can. So like this is the back, and we're creating the sides of the you should see my original like manually cut one. It's so horrible. I actually still have that. So like so many hours sunk into that. Just asked like machine. I just wasn't smart enough to think of how to use the CNC properly. So, more you learn. I was thinking too stupid. I wasn't thinking on how to do this properly. CNC machine. I was thinking too old style. Like how do I cut this out? That was the or with it. I think I might have to go upstairs and get that alcohol spray. Well, it's actually just one side of this. So tactical ladies. That's dry. Type. And then finally, need to think here. Swap. Through. So. I thought. Let's go. That all was the same. Let's get it together. I wonder where that ball went. It's on the floor. Hey, what's up? Hey, Carbonics. You're an infant. But you're an infant. Usually focus like projects So, okay. Now, just going to keep going. So there's 10 layers to do. We just did 2. Train. I'm just going to keep this. Look really good. Third layer. Few gaps in there. This is like way cleaner than that. Okay, so we're making like key ring piece by piece, just layering, just layering on pieces. Just keep going. It's gonna be like this for a while. Dude, still has like sticker on it. They don't want that sticker. It's the third layer, or is it the fourth layer? It's the fourth layer. One of these pieces down here is not quite sticky. Oh. It's going better than I planned. Of 10 layers of this. Up to the fifth layer. Awesome. Why sometimes it doesn't stick? Oh, sticks. Whew. On a fifth layer. Oh, that's kind of nice. They really do blobs instead of strokes. Blobs don't down as quickly. But the cool thing about my pop is that you can take it apart. Just gotta like rub alcohol in it. And just rub alcohol on it. And so as long as you have it. You also wear it down. I am using a lot of these things. Something nice about this. I don't know. So, I don't know what to do. Woo! Alright, we're about 8 layers in. Yeah. 8 layers in. It needs to be like 30 mils wide. That's why I had so much trouble fabricating this thing. Needed it to be 30 mils wide. So it's going to be most. It's going to chew up a lot of power. So I haven't figured out how so much wiring, so much lights and lights. Okay, too terrible. I might have to plug this into the main. I don't think it's possible to try. Pull it self-powered. So. taking a long time. Is this a makerspace you're at? Yes, this is a makerspace. Sorry, like I can't see like messages to check once in a while, but yes, this is a makerspace. Thanks for the like, really appreciate that. But yeah, I could give you a tour later, but we're currently like rushing to build up. It's due tonight. Never had such a never get to do this kind of things in school. So if you're in Australia, this is a central coast makerspace that I am sort of in charge of. That I'm partly in charge of. So you know, if you want to check out stuff live, we have one of the coolest toys we have is a CNC laser. So what this means is that you basically print out anything you want out of sheets. It's kind of what I've done. Simple, broken down frame. So this is a frame for a rig for a mirror. I'm planning to put a mirror in this, but I need like a 30mm wide like mount. So the LEDs are they're gonna be stuck on the inside. So that's what we're making. So we're just about approaching the final layer. Tap. Cool. Yeah, put in the next thing. Kind of got a gap there. Okay, final piece. Yes. Oh yeah. Right. That is a laminated ring. Right. So next, this is great. Okay, so how it's going to fit together is this is now a green that it's kind of loose in some areas, but we don't have time for that. But to do it properly, I do single here, but I think it's kind of like thicker than you. It's not quite like it's thin enough. It's fine. Okay, so how this is meant to work is have a mirror. It's going to go on the side. This. But this is the thing that's possibly going to. I haven't decided whether I want this mirror or like an apex mirror fill. But we're just going to get like. Because like there's a stretch goal that I want to do. Basically means I'm moving this mirror and putting on. So this mirror back here, how it's going to go together is that basically put this mirror bracket around it. I know that's going to fit because we measure the mirror. Over a circle. That basically just press fits onto it. Now, this ring is like it's like a little thicker. So when it goes on top, the bolts will tighten this together and will hold this. So I also have to replace the bolts with thicker ones, but because the bolts will like hold it together, this is preventing it. So that's what's going to hold it. Now I need to replace these bolts with normal ones that I bought. Didn't really quite measure the thickness going into this. Okay, so and then that after this mirror, we're going to put on a Perspex. I would like this out of glass, but glasses take too long to manufacture. So this we can like churn out really quickly. So use Perspex to when I use that Perspex to go over the top. But I need to see if we can like get this green color. Because this needs to be black. I'm going to see if I can find some black spray paint upstairs. I'm just going to spray paint black. I don't have black spray. Maybe I don't need black spray paint. Maybe I could just mount the LEDs for this thing. I want to see what the LEDs look like together, because the LEDs have black strips, and here are all the LEDs that we're planning to mount into the sizes. So the LED strips themselves are black. And because we're going to have them side by side, I might not need to paint it, because the entire strip is black. The entire strip is black. kind of a brush job. I'm gonna have to put this down too. I think we can pull it off. I don't think we need to spray it. Anyway, might need a channel for layers though. I haven't really thought too much about it. So I'm gonna try and go upstairs and like basically chisel out channel and back. See if I can get all the wires to fit down. I need to take 2 layers off. Okay, I'll be right back. Just need to saw some things. Alright guys, like I would take the camera off, but it would be too kind of like it would be too boring because it would be too quick and it's a lot of effort. Oh, thank God, it's cooler in here. So with this mirror, can I see all of time? Damn right you can. You can see off into infinity. Okay. So all we did is we cut like a channel that it's like 10 mils deep, 6 mils that way, so we can like feed the wires through. So now comes the fun bit of upscale. Also, like we need to figure out the programming of this now too. Right. Real life rhythm was missing. Oh my God. I lost an entire day because it was so dusty. I changed the filter on the air conditioner so it's breathable. It's just so full. It's creepy. It's hard. It's all might have to skip the stage 3. I upgrade it. I don't have enough acrylic. So I need like basically 2 pieces of acrylic to put the film on. Like a picture. So I think we're just gonna do the infinity portal just by itself. With no image in the background. It's kinda sad, but how many pieces of acrylic would I need? I think I would need 2. At least, yeah, I think I need 2. Or at least a way to stick. Maybe I could just stick the picture directly on the back of the board, and then figure that out afterwards. So now comes the interesting bit where we have to do the programming part. So you may have been wondering, so this is a prototype of what we're gonna do with our perspex. So we got really reflective film. So this is basically just like a mirror film that we can put over it, but it's also one way. So on the other side you can see through, but on the other side, on this side, especially if the light is on this side, it's really reflective. So we got like a one-way film that we're going to apply to that acrylic, giving us the second mirror. And then I'm going to need, like, to replace the back mirror with like the picture one. I don't even know if that's going to work, but I wanted to have a destination in the infinity portal, but that's probably not going to be possible at the moment. Got so much to do. Stretch goal to be sure. Okay, so I've got so many tools and I don't know what I'm doing. Can you say? Welcome to Shark Tank. I'm already investing in a telephone to sell me the other time device here. Alright, remember, it's not a time device, it's a space device. So it will create space. Is the idea? It will create space. Have you ever had, no room to do anything for a bit longer? This thing, you can basically create space, or at least make things look roomier. So right now we are constructing that portal, right? So we're gonna try to make this thing work. Thing is, like, we had a couple of issues with hardware, but today I visited the shop and got some new hardware. At least got the hardware replaced. Just got the hardware replaced, so we can now hopefully get this going again. So we visited our friend, our engineer friend, and he, instead of like using the Arduinos that we were looking for, he recommended that we get basically an Arduino microcontroller. So this is the thing that will open up the portal, right? This tiny thing. So this is like the legendary components that you find in Cyberpunk 2077. So this is a working prototype of like a transmitter. So basically, here's the brains, and here is basically the transmitter, which will allow our slip ring to wirelessly communicate with the portal. So, have you seen Stargate? So Stargate is somewhere else. Let's see. Okay. So instead of going immediately to programming, I need to mount the LEDs onto that. So we can. Alright, so I may need to go back to the other bench and do this properly. Okay. So don't need this. Not the right size. So we had like these original 2-inch bolts. They're not big enough. Short, like our board just got too thick. So instead we have these 3-inch ones that we're going to install later. At the moment we need to lay down. These LEDs come with a 2-way tape. Not sure if it'll be strong enough. Let's try. So we're taking, we've got like, I don't know, 30 meters of stuff. Just got a line in this. It's 2-way tape. It's got 2-way tape. So strip, stick on, stick on. Sticky. What isn't this sticky? The two-way tape is like that. That's me. I think we might have fucked up two-way tape. That's lost. It's okay, because we got like strategy. Fucked up the two-way tape instead. I thought this was going to be sticky on this side. Okay, so what it is, and I have my own two-way tape just in case we screw up. Just in case. Works instead. Fucking hell. I'm fine. So our own two-way tape. Make up for this. This isn't quite that great. Long is the front. So it's quite off. It's not cutting. What are we cutting off? What are we cutting? Are you serious? What is this tape made of? Cut. Okay. Yeah, two-way tape. I hope it is two-way tape, because like it would be really distressing if I just put on one-sided tape. Peeling off. What is the deal? Just one. Kidding me? Swear this is two-way tape. What? Okay. So peel off. Okay. I need to patch that in. Oh. Just a start. Skip it on. Okay. Alright, you doing it? Okay. Now we can move on. Okay. And Stargate. Yeah. Right, so the reason why this is 30 mils wide is because the strip is 10 mils. Basically, just attaching entire ring to the inside of this ring to a tape. Could fall off. If that happens, spark fluid back on. That's more a problem. Seems very secure to me. Sticking. Simple job. Thing. Environment pretty much wide. So this is the part that's going to do. We're going to have like lights on the sides and then one strip in the middle. I think it's best if I put one strip on the outside, one strip on this side, one strip on the outside, do the middle one. So that's how it works. Okay. Sweet. Alright, cool. That reached the end. The cool thing about these strips is that you can just cut them off. Yes. So you can cut any length of these strips. But it's good to keep the terminals on the end in case you want to power through the other side. Because basically how it works is that it's going to run voltage all the way around. Lost light is trouble with the slides to get voltage. But if you keep the contacts on the end, possibly like feed powerful patterns. There's also one thing I'm not sure. Not sure about. So these okay, so that's the first ring of lights. Before we continue, I want to test something. That is crashing display. Okay, I want to use these LEDs to test something because I don't know if power will go all the way around if I solder the ends together. What I'm going to do is I'm going to like use leftovers on here to see if I can power a smaller version. Crashing display. Okay, so this is the leftovers. This is an LED that what I want to do is I want to make sure that it's well powered. So what I want to try doing, because essentially this is going to come around to the ring. I want to cut this off. I want to see what that is. Alright, so we have like some spare LEDs, and I want to see how should I wire it to get it working on both sides. So we have this Arduino Mega. I think I should just deep dive to. I think I should just deep dive into the new stuff. So we got like this new board that we're going to use. I don't know what the wire is for, but I assume that's like the antenna. Or it is the antenna. Okay, so this is the wire is the antenna. Okay. Alright, how do I do this? Gave me a cable. It's not open here. Nope. I had two of these, but I don't think I have the cable that's required. I do have one here. It's like a mini. Alright. Get out of the pots. I need this. Where'd it go? I swear I had to strip these. I just cut it off. Where did it go? What the? Just disappeared off the map. A clean workbench is the sign of boredom. No, right? But then you have to have these mini adventures for the quest of like the rest of the pin bed. See, like I thought I was doing the smart thing by looking away. Thought I was doing the smart thing by looking away, so I don't have to like. Fuck's sake. I thought I was doing the smart thing. Really, I wasn't. I was trying to not get it caught in my eyes. But then, like, I lose the entire band. Are you serious? This is what I get for being safe. See. See, I just cut this. That's all I cut. I need another one of these. I'm gonna have to like steal some parts. Oh, thank God they have like stairs. You know what the funny thing is? I had safety glasses right on the bench. Oh, I just lost a whole band of pins for no reason. Great. This is going great. Running out of time. We're panicking. Guess we'll find that later. Like, seriously, what the fuck did it go? believe the procedure is that you put in the pins first, and then put on like alright, I'm gonna cut these now. Wait. Seriously, like we just lost a whole bunch of pins. So that shot away that way. So I think it's gone over there somewhere. Oh wait, I think I found it. Yes, did it. Found the rest of it. It's too late. We already stole some parts. Zoom in and enhance. Stop looking at my face. Yeah, sorry, I'm trying to like read the stream, but the stream is right there, but I was trying to find. Or just plain lazy. It flew to your right. I'll rewind a bit. Yep, it went right. 5 fell off the table. Yeah, okay. Thanks. Yeah, sorry. I should have realized chat had my back. Flew to the right. But we have it now. It's all good. It's like near the door. It's so tiny, like off the floor, so. But yes, like a neat table is a sign of boredom, but you have like mini adventures to like find the shit you need. I don't know how like electrical engineers do this, but they basically just put the pins on the breadboard. They put the circuit on top, and I have no idea how they do that without soldering this together first. Because this breadboard is just something else. Just the stiffness, amazing. Okay. So I press this down. Should not break something. Okay, so that's secure, somewhat. Now we just solder it all together. Big brother's looking over your shoulder. The patient needs to be cooperative. I know, right? Which is why we need a gun. This antenna is like... Thanks for having my back, chat. It flew to the right, so there it goes. Found it. Found the missing band. Okay. Nice. So we're just adding pins to this board, and now... So here's the thing, I'm currently taking a leap of faith because this is a replacement board, but it's not the replacement that we need. Because this is the replacement it's not the replacement we deserve, but it's the one we need. And this is not on. So the story is, we initially were going to go with the Arduino tech, so we got new Arduinos. We got new Arduinos and Arduino Mega and an Arduino Uno because we wanted them to communicate with this wireless transmitter. This is a wireless transmitter that you usually find in remote control cars. But our original boards wouldn't work, so we popped down to the shop to get these replaced. So we got them replaced. But we called our engineer friend. He said, "Hey, this board is way better because it's got a wireless transmitter built in, so you don't have to fuck around connecting it the right way. So this is built in, but the reason why I'm kind of nervous soldering this together is because he said, So what do I owe you for these chips? It's like, oh, just buy me some new ones. I don't even know the price on these, but I'm hoping it's not $1 million. So I said, oh, just buy me 2 of these as replacements. I'm like, okay. I didn't really check the price. Hopefully it wouldn't screw me out of $1 million. So, yeah. So hopefully and the thing is, like, you just return these to me. He's like, okay, in what condition? Can I, like, put pins on these? Or do I need to remove the pins to return them to you? So that's why I'm kind of nervous about soldering these pins on. Because I'm nervous about soldering these pins on because once you solder them on, it's really hard to take them off. And then, like, am I voiding the warranty by doing this? Technically, like, you can't really operate this thing without putting these pins on anyway. So it's kind of hard not to. I mean, the first thing you would do to use this is to solder on these pins, so it makes it way easier to use. Plus, you need these pins to connect to the breadboards and get like sockets together. So this is technically what it's built for, but a little nervous because I don't know how much it costs to buy one of these things. Like if it's as much as the Arduino Mega, it's not going to be too difficult to replace. But I didn't look it up, so I could be soldering together military hardware right now, which costs like $1 million. So I'm a little nervous soldering this. And just to look professional, I'm going to use a magnifying glass to see what I'm doing. The pins are tiny. Yes, Mr. Freeman. That light does nothing. So this has like a tiny LED light to light, so it's not so dark to see through, but it just does nothing. You see here, this is where we should begin the incision. So using one of these things turns you instantly German. Using one of these things suddenly makes you a German surgeon. It's kind of what it feels like right now when you do the pins of soldering. Instantly turns you German. This is kind of a mess, but like it's hard to organize like all the random scraps that you need. So I'm also trying to desolder and make this neater. First, I need the sponge. It's way too much solder. As long as the pins aren't touching, we're fine. From time to time, you do need to clean the knob. Not to use too much solder, otherwise it will become a droplet. It becomes fat. And it is fat. There's a potential to contact other pins, creating a short circuit and malfunction in the system. Which is why you need to keep the pins completely separate, all the other ones. Please don't let this be military tech. Want to be arrested for like soldering military tech just to make an infinity mirror. I've been playing with joint terminals and fun with just a dew-point crimper. Huh. Need to figure out what that is. You need to explain what that is. I haven't never heard of. I don't know what that looks like. But for now, we're just doing solder and breadboard. Ah yes, I will clean that tip, Hans. We don't use a sponge around here, we use copper wool. Because we have copper sheep. My first real solder job was a very small chip onto a PS1 to bypass security on the CTs. Yeah, I can imagine what that's like. Holy shit. Okay, so do you want like the super? This zooms in more? This camera is amazing. I think that's as far as I can zoom without moving the camera closer. And you're gonna be seeing a lot of my arm. How bad my complexion is. Okay, but can't imagine like soldering like computer chips. Oh crap. Right, just get on the contact. Okay. We're not even soldering anything together, we're just soldering like pins. Keep it steady hand, Hans. Nearly into the goal. Wow, I don't know why that's not making contact. Usually like this sticks to it very easily, but sometimes it just doesn't. I don't know why. I think it's because like you need to heat up the entire, like both contacts. If you just heat up one, it doesn't. It's not as good. Can't overheat it either, otherwise you like burn a lot of the PCB plastic. Sometimes it just doesn't want to cooperate. That one there is like half soldered. It's like unsoldered on the other side. Just get on there. Usually these things are super sticky. Sometimes they're not. Nice. Sweet. Nice. Alright. All soldered up. Cleans. Make sure the tip is clean. I haven't done electronics since like year 10. Yeah, not bad. Alright. We have a soldered chip. Ah! Please don't bend any pins. Just created you. Okay, so we managed. It looks good to me. Doesn't look like the pins are contacting. Let's see how focus. But the pins aren't touching. Um, Pins aren't really touching. So looks like it's good to go. Although I'm not sure why, but some of the pins are not. It's weird. So pins are supposed to be straight on line, right? Some of them are crooked and bent out of place. Well, like they're crooked and don't have the same height. So those are like really cheap pins. They just got pushed up instead of into the breadboard. Not sure what to make of that. But pushing it down into the breadboard should all make contact now that it's all soldered together. Okay. Yeah, okay. It's fine. Probably not the right way to lift it. Those pins are really jank. I want this on the end. So I can put the USBs in easy. Okay. What were we doing? Alright. We're going to experiment with this strip. Because like usually like this has a power cable. So we're experimenting with this strip of LEDs. It already has a power cable attached, but I want to like link it up like a ring to simulate the bigger ring we have back there. I want to like link the power terminals, at least positive to positive and negative to negative. Hopefully we won't have a short circuit. I want to link the ends together and then like the power to actual power. So I want to drive that. I want to drive it with this because I already have a program ready to go to drive the LEDs. But I want to know if this. I want to know if wiring it up this way will do that. Yeah, I know, bro. Yeah, why? I don't know. I'm good. 30-inch monitor on a PC. Okay. You are large. Liquid flux is more man-environmental. Yeah, you reckon? Yeah. Okay, so we're kind of like breaking into these contact terminals. Just want to like cut it open, make an incision, see how this is wired together. Oh, I see. So that was like shrink wrap. Okay, so the green, looks like the green is the data cable. We got power cables here and here. Okay. All right. Okay, so just supply power to this thing then. Yeah, USB. Uh, I should actually buy more shrink cable. That thing's nice. Provides a better housing than electrical tape, that's for sure. Okay, so this is the first time powering up this thing, so hopefully we don't explode. Hey! Stop, you Nazi! Jeez, alright. That's gonna be on the stream forever. Use a plastic spudger tool. Level them out? You reckon? Like, how... I don't have everything. So when you say spudger, is that the, like, the sucker syringe that you use to, like, suck off the, solder? Is that what you're talking about? Why not leave the lights at dead end? Because I hear, like, if you power them from both sides, it's easier. Well, because I'm worried that because I'm using, like, such a large ring of LEDs that it's not going to be powered properly. So what I'm going to do is I'm going to like power it from both sides so the wires themselves aren't resisting. not sure. Part 3. Okay. Well, I hope he comes back. We had a good chat. I hope he followed and everything. Don't think I can even up the pins, but no, I can just cut them short. It's fine. Okay. Now that's powered up. Just gotta like Google how to put the Arduino set onto Arduino. Arduino. Wireless. Yep, sure. Rant and options. I think I have with Flash. I think I have the Arduino USB. For programming a low power lab ports and install Arduino package in your Arduino IDE. Okay. First add the Arduino core JSON URL to your board manager. Right? So I'm gonna do all that stuff. Let's add the core JSON definition URL to your board manager. Tools, board manager. Preferences. Final tools. Package low power lab index.json. Okay. Then in board manager you see AVR and SAMD by power lab. Sure. Once the required packages, the new boards will show on your tools boards menu. Okay. Alright, I guess we'll just install everything. Tools. Tools. Boards. Board manager. SAM boards. Arduino. AVR boards and SAM boards. Install. Install. So currently, like, trying to get the necessary software running on our laptop. Okay. Once updated for the new boards will show tools boards menu. Okay. There's now a programming guide for Multinos. It helps you get started with libraries and programming in Arduino IDE. Please check it out if you're new to Arduino. Steps. Alright. So it looks like I can just go into Arduino right now, right? Assuming that's digital pins. Okay, to get this running, I need this power. Is it possible to just use this? I don't need to crimp anything. Okay. White is ground. Wow, barbarians. Well, where are the 5 volts at? Volt in. I'm assuming that's 5 volts. Okay. So, 5 volts. 5 volts. This is the ground. It's not going to short circuit because these lines are separate. And if I connect these to power, that light up. Nope, guess that was too easy. So I have the data cable too. I need this data cable somewhere. Alright, so that's the data cable. What if I could do VS Code? Wow, the Arduino is here. The Arduino USB. Okay. So, if I have this correct, what is the data? Define pin 5. Okay. So, this should go to pin 5, which is here. I wonder if this will drive it. Just gonna get my multimeter out and make sure the voltages are going through. Ah, crap. We have voltages. Okay, so we have voltages. COM6 is what we need. We want to transmit the strange port. Ah, we uploaded the sketch. Is that not working? Doesn't look like it's driving. No? Doesn't look like it works. Try this with the Arduino Mega. Or unless I could Google search it. I think that's USB. Yeah, I definitely have that one. Okay. USB. I wonder if pretty sure I have that right. I wonder if I could upload just Blink there. Okay, so we've got an LED blinking. Cool. Define pin 5, changing this on Trinket or Gemma suggested changing this to 1. Oh yeah, that's right. This doesn't have 44. How many does this have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 20, 21, 22, 23, 24, 25, 26. Yeah, so 26. 26, just gonna have, 2. So 2 particles on there. Put on pin 5. Just, yeah. Alright, pin 5, delay valve, okay. I don't think there's anything else to do here. Okay, it uploaded just fine, but it does. Hmm. I'm gonna try pin 8. Hmm, that's weird. Doesn't seem to work. Thought it was simple as like soldering it to a pin. Apparently not. Something's wrong. It's not working. Still doesn't work. Five volts and ground. D pin needs just to go to a digital pin. Why is it not working?
Hey guys, John from John's DIY Playground. Today I want to show you some Motinos. I use them in my home automation system, but you can use them for different types of programs where you want to have two-way communication. It's a really nice device. It's Arduino based and it has a radio transceiver included on it. So I have three different types here, and I have this FTDI connector. So FTDI is needed for most of the Motinos. In order to flash them or to talk to them on a routine basis, like if you're having it plugged into a Raspberry Pi gateway. So I have just one of these, and I usually use them to flash all my different Motinos, at least the first time, then you can program wirelessly. Then, after that, if you need something more full-time USB, you can buy a Motino USB, as it's called, with the FTDI chip on it. I use that for my Raspberry Pi gateway module, and then I don't need this FTDI. It's very nice. This is the base Motino here on the lower left. It's the least expensive of all the Motinos. And I'll show you how to choose what type of Motino. Basically, they have analog digital inputs. The Motino Mega has a lot more than the base Motino and a bigger chip as well. And it also has, on the Motino Mega, the option for an external antenna. Okay, so here we are at the lowpowerlab.com/shop URL. You can see it's the web store. There's many good products here. They've all been developed and customized by Felix at the Low Power Lab shop. PC board quality is excellent. All the parts that I've received have never had any problems with. I know they're functionally tested. Component Motino here, so that's in the plans for the future. FTDI adapter, you also need that, like I said, for first-time programming. And then if you want to order transmitting on the base 45 milliamperes versus the high power output is 130 milliamperes. The guide It's showing how the radios, these RFM69 transceivers, are married on the underside of the Motinos. There's many different options in addition to the 69H and HW. There's these LoRa at this Motino pinout area. Very important, because what's interesting to know is that the transceiver has to use certain pins in order to talk to the transceiver. Normally, if you don't get a transceiver, you can use all of the pins for analog and digital input-output, but when you have that transceiver, keep in mind that the certain pins you cannot use. So, for example, digital 2 and digital 10, 11, 12, and 13 are all used by the transceiver, no matter which one you choose. And if you do have this flash chip, in order to use that, it's also using digital 8 and then 11 through 13. So those are pins you do not want to use for anything else, and just leave them dedicated as keep outs so that the transceiver can do its job. Alright guys, so that does it for today's Motino introduction. Hopefully you found one that interests you. If you do go with a Motino USB and one of these regular Motinos, in the upcoming lessons, as part of a 3-part series, I'm going to show you in part 2 how to put the Motino together, and then part 3 how to program it and set it up with your home automation system. So please give a thumbs up if you liked it, and if you're interested in the future videos from me, please hit the subscribe button. This is John from John's DIY Playground. Have a great day. Hey guys, it's John from John's DIY Playground. In my first Motino introduction, we show you about the different types of Motinos. Today we'll assume that you've bought one, and I'm going to show you how to put it together. So stay tuned, and we'll go through the steps you need to get the Motino put together. Now I'm going to go ahead and get the Motino prepared with the header soldering and then the FTDI connector and the antenna. I'll show you each of these steps. We've got a good tip here to share. Take a breadboard of any size and put the headers onto the breadboard ahead of time, like so. Helps keep the pins nice and square so when you get things lined up. Before you solder, you've got everything in line. Just take your Motino and put it on top like that. And then we go ahead and take a soldering iron. I've got a soldering station. I reviewed soldering in one of my other videos. It's a 60-watt soldering iron that doesn't weigh as far as before. In this case, like what I start tonight, and then we'll go ahead and do the FTDI connector. I think it's your own preference if you want it to be pins up or pins down. For me, I find that it's just nice and easy, since I'm on the breadboard already, to go pins down like this for the FTDI connector, and I just usually start to the other side. The final step up, as you can see, got the FTDI connection all soldered up. As you can see here, we've taken it off the breadboard and flipped the board over. The final step here in getting the Motino ready is to get the antenna that came with your package. It's in a very precise length for the correct frequency side of the pin soldered into the antenna hole. So you don't want it on the side of the pins, the antenna wire, so it can solder onto this antenna. Let me get it set up in the fixture. Got the antenna wire hooked up, holding the board in place. And all I have to do is dab it with a little bit of solder to get that set and ready to start programming this Motino. How to solder your Motino and get it put together. In part 3, we'll tell you how to program the Motino. Hey guys, it's John from John's DIY with the different types of control. You can measure. So stay tuned. On this first box here, which is a Motino with the RFM69 transceiver, an external LED that we'll be controlling, and a photoresistor that will record the light levels on the upper right to be, which is going to be also a transceiver. It's a slightly different looking Motino because it has the USB and FTDI chip built onto it, so we use a micro USB to USB cable to plug it in physically by wire to the Raspberry Pi and the Motino USB. I won't go over that today on how to node test it out. Then finally we have software over the the code that we're going to write to our Motino, which is shown here. I'm on the CodeBender website. The second piece we'll go over next is going to be a code that we have to modify in the metrics.js file in a GitHub site. So, but basically, code right now is about 195 lines long. I won't say too much about it since there's so much for Motino, very high of it, and so on. The onboard LED, we're going to tie to A5 and we're going to give it power from A2 and just set A2 as high to feed it that power. And then our external LED is on digital pin 3. Now, really important thing, guys, is pay attention to pinouts of Motino because it has that radio transceiver and a flash chip for over-the-air reprogramming. It uses a lot of existing pins that you might think are available, but they're not. So do not try to use digital 2, 8, 10, 11, 12, and 13 whenever you're designing a sketch with your Motino. Next, for the flash circuit, we're going to be flashing it every second, so I'm just going to set the blink time as 1,000, which 1,000 milliseconds is 1 second. Checking our photoresistor, we're going to do that every 30 seconds, so that's what I do on this line here. We're not using time delay functions, we're using timers and using the millis command to check against these, I guess, moments in time. So they're not exactly precisely 30 seconds apart, but let's say it's very, very close to 30 seconds apart, and the flash time is very, very close to 1 second apart. Setups, pretty standard, just like Arduino. You need to tell the pin modes if they're inputs or outputs. This is a section, the setup, of course, is only run through one time. We're initializing our radio. We're checking for if we have the E² flash chip on our Motino. And then finally into the loop section. Loop section is not really that big. There's just a, and then finally into a loop through one time. Actually precisely 30 seconds apart, but let's say it's very, very close. Setups, pretty standard, just like Arduino. You need to tell the pin modes if they're inputs or outputs. This is a section, the setup, of course, is only run through one time. We're initializing our radio. We're checking for if we have the E² flash chip on our Motino. And then finally into the loop section. Loop section is not really that big. So, we're checking for through one outputs. Against these, I guess, moments in time. So they're not exactly precise. Check. Link time is 1,000, which 1,000 milliseconds is 1 second.
Not sure why that's not going. Arduino. Adafruit learning system. That's 2 LEDs. Strip. Love some good LED lighting. Schematic. Okay, so wiring strip is really. Oh, we don't have RGB. We just have addressable. Guide for W2A. We want to be addressable LED strip. Okay, yep, got it there, nice, powering, okay. Need the pin headers, fine. Schematics, connected to 5. That's what we did. External power source. Adafruit.
Are we using Adafruit? Sure we are. So magic of NeoPixel, sure. NeoPixels in general, blah, form factors, strips and standards. Yep, okay. Details, two strips. This is where I want to be. Do I need to do this again? Text edit. And Visual Studio. That's not what I want. LED count, LED pin, and here, see. Nothing is happening. Strip begin, strip show. Alright. Pin count, sure. Refer NeoPixel H, that's all we have. I need this pin. Alright, well, I need to look up. Just gonna go die. Just gonna go die. Alright, what digital outs do I have? D4. Yeah, let's try D4. It's kind of new. Might try the old band, if that works. Pause between pixels, fine, pin, non-pixels, delay valve, sure. Trinket, don't need these trinkets anymore. uploaded, but nothing's happening. Let's try Blink again. So it's blinking with the LED. So that works. What about this? Let's just try and hook this up. This is the original. Five, four. This doesn't work, then maybe there's just something purely wrong. This works. So I hope this works. Still going to pin 4. Still nothing. Doesn't work. Okay, let's try something different. Let's try the good old Arduinos. I'm not sure why the Multi-Eno doesn't work. It's supposed to. I was given guarantees that it would. Yeah, let's try the Uno. Lied to me. Really? None of these work? It says use pin 6. Try pin 6. Still nothing? Okay, so that works. So the Uno works, but why doesn't this work? What is Uno pin out? So pin 6. Okay. Pin 6 is both. It could be both analog and digital. Okay. Okay, so that works. It's just the digital driver that doesn't really quite work. Alright. He did say, like, might be another way.
Next, for the flash circuit, we're going to be flashing it every second. So I'm just going to set the blink time as 1,000, which 1,000 milliseconds is 1 second. Checking our photoresistor, we're going to do that every 30 seconds. So that's what I do on this line here. We're not using time delay functions. We're using timers and using the millis command to check against these I guess, moments in time. So they're not exactly precisely 30 seconds apart, but let's say it's very, very close to 30 seconds apart, and the flash time is very, very close to 1 second apart. Setups, pretty standard, just like Arduino. You need to tell it pin modes if they're inputs or outputs. The setup, of course, is only run through one time. We're initializing our radio. We're checking for if we have the E² flash chip on our.
That's what I'm doing wrong.
And then finally into a loop section. Loop section's not really that big. There's just a couple of subroutines, let's say, in here. The first is checking for radio receiving of a message. So this is where we look for our incoming messages. I'm using the message of L0F for turning the external LED off. And I'm using LOF and LON, not a 0. I'll make sure you use an O. Again, this code will be on GitHub, so you hopefully can't mess that up. And then turning the blinking onboard LED on and off, again, we're not using delay, we're just using millis to check against the last time we blinked, and then deciding if we're going to turn on or off. And same with the photo resistor check. And next I'll show you how to set up the metrics.js file in your Raspberry Pi so that it knows how to interpret these messages and how to send the LOF and LON commands to the Motino back and forth. Now on to the second of the files that we need to modify or have available. This is on our Raspberry Pi. You go into a program I'm using, WinSCP, to tunnel into my Raspberry Pi. And what we're looking for is this metrics.js file. You double click it, it'll
Yes,
open an editor,
did it.
and you will get
Motino is up and running.
JavaScript, of course. I am adding in these lines here for the DIY Playground device. I'm telling it for the light level. I'm looking for an expression or data that comes to the Raspberry Pi over the Motino USB with the category 9905. And then I'm actually going to send it a number, 0 through, let's say, 1023 for the relative light it's measuring in the room through the photoresistor. And I'm calling the units of measured level simply. We'll see that on the gateway display shortly. And then for the external LED, I actually have two lines of code here. The LED off status. When I see the data 9900 come through with a colon and then a 0, I'm trying to tell the gateway that I have a status of off. I do that after it's issued the command to turn it off, so it's either turned off or turned on. And then conversely, you have this LED on line. It has to be a separate name for the JavaScript to work right. And you call that LED status again, but you change the values to on. And again, you can see 9900 is the category, then the value is number 1. The other piece of code that you need to put into this file is a little further down. It's in the area of the default mote definitions. So this is the mote definition file that enables the buttons that I'm going to show to control the external LED. And when it's going on or off, it goes through these different types of buttons. You can set button color. You can tell the button whether to show up or not, conditionally or unconditionally, depending on what the status is of the LED currently. And I'll demonstrate all of that next in the example. And before we run our demonstration, here's just an overview of what the final thing looks like on the breadboard. You've got your Motino hooked up, and then on the breadboard you'll take your photoresistor, hook that to pins A2 and A5 like so, and then you'll hook a resistor 220 ohms from the A5 to the ground pin like so, and then another 220 ohm resistor over here to your LED, and the other leg of the LED goes to digital pin 3. We have our gateway dashboard pulled up now on our computer with the IP address of the Raspberry Pi. You can see it's already detected automatically here at the bottom. Number 121 is the gateway node ID number, but it doesn't know what it is yet. So in order to define that, you just click on that area and you have to select the type. Now you can see there's a John's DIY example in the drop-down list. You can put a little description in here, like if you want node 121 example, hit tab and then go back home and you'll see it pop up here. If it's big like that with the icon, if you hit F5 to refresh, it'll make it small again, and then it actually categorizes it in the list. So you can see it's receiving data. It tells you how often it's last received an update, so it was 11 seconds ago. If I click on it now, I can see that it has a light level of 14. I'll take a flashlight right now and I'll put that on the photoresistor. You can't see me doing this, but I got the light on there now. It's going to update every 30 seconds, so there it just jumped to 435, the value. So that's working well. You can also check on status of things if you take a look at the control panel here. You can actually send the commands. For example, if I want to tell node number 121 to turn the LED on, it's LON is what I'm using as my command. I hit the send button and it'll send that command over, and we can see if it did it. I can look at my Motino and see that the LED is on now. Actually, and that popped up the button, and you can see the LED status has now been commanded to on, and we're recording that. If I hit this button here, it's sending the command to turn the LED off. It takes it some time before it sends the command if it's waiting on other things or doing other things, but it'll send it. When it actually does do it, it acknowledges the message, and it'll actually change the status by itself, and then it changes the button from off to on. So in short, that's how this thing works. If you have any questions, please leave them in the comments below. I'd be happy to answer them for you. And I hope you liked it. Please give it a thumbs up if you did, and please subscribe for future videos. This is John from John's DIY Playground. Have a great day.
Oh, right. Maybe pin mode 5 output.
Hey guys, John from John's DIY Playground. Today I'm going to review this switch mode kit from lowpowerlab.com and /switch mode where you can find it on the internet. And what a switch mode is it's a smart switch, kind of an Internet of Things type of switch where you replace your light switches in your house with one of these or several of them throughout the house. They operate wirelessly. They do need the 120 volts of power, of course, but they talk wirelessly to your home automation controller. Could be a Raspberry Pi, and they can talk to each other and work together. So let's get this thing opened up and I can show you what's inside. Quite a few parts today, but I'll show you step by step how I go through it. There's a laser cut acrylic piece that's going to be one of the show covers, back protection cover here also. There's a couple circuit boards. One's the main switch mode board. This is actually supporting the buttons that are going to be a 3-button setup on our configuration today. The main relay that powers one of the circuits on and off for controlling the original lights. Another relay, buttons, button covers, caps. We got a lot of headers. So let me get this all organized and show you how it works, how it will go together. This is the heart and brains of the thing, like I said, Motino. It's a Arduino-based microcontroller we can flash code onto, but the code in this case is provided for us in the kit. And we're just going to flash it, and it'll be kind of plug and play once we get this thing assembled. If you open your web browser to lowpowerlab.com/switchmode, you'll get this page here, and just scroll down a little bit and then click on Assembly Guide. When you have the Assembly Guide here, as I'll be following today, it's got detailed step-by-step instructions on how to assemble the kit. The only surface mount component is right here is this diode, and it's not that hard to actually solder, even with standard soldering equipment. And I'll go step-by-step through here. Everything else is through hole. And on each little picture, if you click on it just one time, you'll see it zooms into a nice, clean, clear, with detail, and actually has some nice hints and tips on a lot of these pictures about orientation of the LEDs and trying to get everything just right. So I'll go through this. I've got a revision 2 kit, so if anything's different versus these instructions, I'll let you know. And if there's anything else that's different, since I do also have a 3-button kit with 2 relays, I'm building it in such a way so that I'll have 2 different relays so I can control 120 volt load here and then a separate load here. And then the 3rd button will be a virtual button. So let's get started on it. So I'm about to get started with the assembly here, and I'm not going to show all the assembly steps because that online guide that's on Low Power Lab is very good and didn't need to show everything. But this kit does have only one SMD component. It's this diode that I'm going to start with. It is polarized, so you have to watch the silver dot. Make sure the silver dot is towards this side of the board, and it's marked with the arrow, with the arrow points is where the dot should be. So I'm going to go ahead and solder that on. The other thing I meant to mention was this kit has several different varieties. I'm going to put together the 3-button type today, and 2 of the buttons will be switchable, up to 10 amps and 250 volts each circuit. So there will be 2 relays going in on the circuit, and the 3rd button is like a virtual button, so that can be used in your home automation system to
What?
control
It's
everything.
5, so special.
You can just have the button with the green and red LEDs giving an indication of something. For
6.
the garage door is up or down. So let me get started with the assembly of this, and then we'll move on to showing you how some of the bigger pieces fit together after all these components. Okay guys, so I got the smaller of the 2 circuit boards nearly finished, and I noticed in following some of the online instructions a couple of differences on this board compared to earlier online instructions and pictures of the boards. The layout's changed slightly, but it's well labeled. It's easy to pick up on. I got 2 transistors here because I think I've got the 2 relay system instead of just one, which was in the pictures. Also, the LED placement is rotated a little bit, but that's no problem. It's well marked. The placement of this fuse and varistor are also slightly different, but also marked well. And so I'm just going to get started and get these last few big components on this board, then I'll be done. But another tip I can share is when you're soldering the headers on the Motino, don't be an idiot like me, because the one side takes all 13 pins for the headers, but on the other side of the Motino, you only solder up until pin number 7, then you stop. So if you do keep soldering and leave all the pins on, you'll have an interference condition when you try to put the Motino down on the board, and the solder's in here, it'll run into this power LED and also interfere here. So just a word to the wise and learn from my mistakes. So I'm done with the main board here, this power supplies plus the Motino section. All the headers are on. There are no components that actually go on the bottom. And it's a tight fit for this power supply and these 2 relays on the board. I mean, there's like really no space to spare. Felix didn't waste any space. He populated it really nice.
It's like I can't.
Goes on here like so. Sits in there like that. And that's your
It's like I can't upload via.
So what we're going to do next is work on the
It's like I can't really upload. This is
really the interface for the switches, and I'm going to put on the LEDs.
Visual Studio Code. Doesn't look like it's Dino's.
Alright, we've got the switch part, or the shield as they call it, completed. There are no components again on the back side of this board. And it's pretty simple. There's 3 resistors on this side, 3 on the other, along with 6 LEDs. And you can put the switches on in multiple colors. They give you yellow, green, and white buttons. So that goes like that, and then this cover goes over like this. And what we're going to do next is we're going to mate this top shield with our Motino part. And we'll use headers to go through these various points here. So I'm going to attach those together and show you what it looks like after it's all put together. Okay, so we've got the top part of the shield mounted to the bottom part. There's several headers that you had to solder here, and then on the other side, another pair, and then another bunch here. So that's how you join the 2 halves together, and it's a nice tight fit. And the next thing we're going to do is just put the back acrylic cover on to protect the circuits, and then we'll head over to the computer, and we'll hit the programming port here, and get the software in the Motino. Okay, on the software side of things, to get our switch mote running, we need to follow a 3-step process. The first step is going to be to load
it's like
the software
Visual Studio Code kind of
sketch onto our Motino.
to the Motinos.
And this sketch can be found over on GitHub. It's also available through the guide on the Low Power Lab website. And you just load it into an Arduino IDE. All these settings here are not to be touched. You don't need to change anything. Like I said, this is the first of 3 steps. We're going to upload this sketch to our Motino. When I'm done with that, then we're going to open PuTTY as the second step and actually configure the Motino and our switch mode. And then we'll load a final sketch. So let me upload this now, and then we'll start the PuTTY step. Okay, guys, I got the initial config sketch loaded onto the switch mode. And one other tip I have for you all, if you're using an FTDI connector to flash your Motino, and it has a micro USB to...
Let's try this again.
Just like with Arduinos, the cable can make the difference.
6,
If you
7.
have communication issues, so keep that in mind. If you cannot communicate between the computer and your Motino or Arduino, check the cables, swap
6.
cables, and make sure it's not the cable.
Okay, 26.
Anyway, another tip just to pass on to y'all. One of the things when we do our configuration is I'm going to tell it what node ID I want for my home automation system for this new switch mode. I already have one in my system, and it's node number 69. So I'm going to make this new switch that I'm programming now.
Alright, so finally we'll get down to this.
Now, just a one-time thing. And to do that, we're going to use PuTTY. So I found that my Motino is sitting on COM number 8. So in PuTTY, you just change that here. And then for the baud rate, you need to change that to 115/200. And after that, just click on Open. And you'll see here, it's communicating now with the switch mode. First thing to check is the first frequency. I am on 915 megahertz, so that's good. Now, node ID, so if I hit the letter I, like I said, I want to make this number 70. Hit enter. So that's no problem. So now you can see it's actually reporting back that it is node number 70. Network ID, that needs to be the same for all of your nodes in your network in your home automation system. In my case, I use the number 101.
Oh, that's true.
So that's taking on that value now. The RFM type, W or CW, I can just show that what the options are. I actually have the higher output Motino, so the HW, so I want to choose a 1 here. So now it's HW.
So it works with this.
Make sure you have that set the right way. So
Why not that?
And then it looks like it's pausing here on me.
Oh,
check
is it?
Connections and we'll come back.
I understand.
Sorry about that.
Digital input doesn't work when you're supposed to start from this end.
Click the video shortly after anyway, because I don't like to show my encryption key, which I use
All right.
for all my other home automation needs. So anyhow,
I did it wrong.
that was step
That's why.
2 with the putty, and now I'm using a program called CodeBender. It's actually a website, codebender.cc, and you can set up an account there, and it's really
Might look at it later to do wireless stuff. Okay, so the digital input needs to happen on this side. That's why it's not working. Just need one digital pin on. We'll put a header on there, actually. Why not just use a header? Da, da, da. Do, 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 do. Do, 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 do. Do I need this in there right? Just doesn't work. But I got the LEDs running with the Motino finally. Just needed one line of code to get that started. Pretty good. Just gotta solder that header on. Okay, that's the beginnings of secure. Nice. Okay, so we put a header on there. Hopefully now this will work as intended. Just need the proper cables. Mm, 5 volts, not a pin. That still doesn't work? What is up with this strip? Telling it to go to pin 4 like I told it to. Oh, it's just loose. Okay. Whoa! Now I have the strip that works. Or do we? Hey, hey! That's what I'm talking about. Found it. Yes. Yes. The power. Power overwhelming. Mm. I don't know why they put on like a digital out here if it was just going to be entirely useless. All that this could be used for is power. Okay, so back to the experiment that I was going to do. I was going to like just supply power on this end as well. So I was planning to hook the power up as well, and I was wondering if that would affect the LEDs. Would it provide better power? I don't know. So I'm just going to turn these wires into pins. Probably wise if I unpower this. Useless. Keep the pins though. Pins are useful, but this is useless. I have been tricked and bamboozled. Alright. What's I gonna do again? Okay, so now that these are... So if I took out these and put in these power cables instead, would that also... Oh, weird. Okay, so let's put digital in digital. So it does work. So what if I put in all the power? Well, it looks still works the same. Alright, that was kind of what I wanted answered. Alright, so I just gotta make sure the arrows are the right way, and just gonna make sure the arrows are the right way. That is very good. Okay, now I've got to figure out how to get the wireless on this Morte-Ino working with this one. Okay, first of all, I'm going to transfer this circuit onto here. Okay, so this I'm planning to... Is there even enough space for me to put this on this tiny breadboard? I think there is. And make this a little more compact. Okay. Put another Mortino on instead of moving this one. Let's do that. There's the other one. Mortinos. Forget I need to put on the header for this thing. Also need more. Didn't I have more? I thought I had more. Did I put it back? So. Yes, more headers. Okay. More header pins. Hope these aren't the cheap ones. I don't know why I put the one I needed back. Oh, still too wide, huh? It's going to be a very tight circuit. Let's get this prepped. So I just need the data to go through a transistor. Oh, this. So yeah, we'll just fucking solder this on. It's a very tiny. Just a bigger one. That over there. Ah! Severely not balanced. Ugh. These tiny shitty mic. I can only see through one eye. thing is kind of shit to use. Just can never get the right position on this. Okay. Now that's tangled. Everything is everywhere. Scrolling down the corners first, because that's best practice. Okay, now I can go down the rest of the pins. Did I just do this on backwards? Might have. I don't think it matters too much. I think I put it on backwards. I'm sure it's fine. I don't think there's... Oh, I don't get the reset button. I put it on backwards. Great. It's going to be challenging to get out. Awesome. Oh, good job, man. You put it on backwards. Awesome. Just freaking awesome. So great. So good at this. Now we do the whole... Do the... Yeah. Did it backwards, but we realized... Good thing we realized it early. So now we're going to do this whole desoldering thing. We take off the solder. And I'm just going to nice screw it. Is this the right thing to use? Let me try this. It's huge. Soldered it up backwards. I don't know how I'm going to pull this off. Quite literally, don't know how to pull this off. It's kind of permanent. It's not too bad, hopefully. Okay. Mounted it all backwards. I am great at this game. I can't really do much. I'm gonna have to just deal with it being like this. Okay. Alright. Alright. Okay. That was fruitless. Do it. We're just gonna continue soldering it on this way, I guess, and then we'll just, because like the pins are basically, basically the pins are like pointing upwards, which means we could just put pins directly onto the board. So this might be a blessing in disguise. This is not the way I originally wanted to solder it on, but you can still make it work. In fact, thinking about it, it's entirely possible that the other way is probably the way we didn't want it. Fucking, we don't need this anymore. Got it working. Got the prototype working. I don't like the solder on this end. Okay, just gonna have to deal with our mistake, but it's not the end of the world. It's fine. Just mount the pins directly. Okay. What were we doing? We had a capacitor. We also had that. Had a capacitor. So this is the longer leg. That. Need a capacitor going there. So we just need a male, female pin. Which this is not. This is one I made, so it's fine. Stitch in here. Speed. Just B. Stitch in. Just hook it up like that. I know it doesn't look nice. You don't have to tell me. It's pretty shitty. Okay. Then you never find the leads you want. Okay, we'll make this ground. Gray is ground. These are better leads than the ones I got supplied with. Okay. We got the capacitor, and then just want it running again with the LEDs. So to ensure a smooth operation, LEDs are going to operate off that power supply we just made. And the data input has to go from and have green, we have brown. Wait, there's a white one? It's not nearly as white enough. Can I remove the pin from this? Oh wait, no, this is good. Alright, so I think I set it to I set the pin to pin 4 was right here. Here. Then took out the resistor. Resistor's gonna go across board. That's how you're supposed to use these. Then from out over here, we'll have the LED out, which is also. So this is the data connection. So that should be connected. That is the circuit. Then we will flash it with our program. Tools. So it's connected. COM8. That was... Oh, yeah. It's just one of these things is loose. We now have... our LED strip working. That's great. Oh, I might need several of these. I might need to connect them up in parallel. I could, I might need to connect them all into one big ring, because I need to make it a coil, because I think just the way this is set up, it's not going to, it's only going to accept one data line just by looking at what this is. I'm gonna have to like, I can tell what position. I can tell, like, I have to basically just organize this into one massive strip. Because I thought I was going to be able to do 3 lines separately, but that means I need like 3 more controllers. At least that's how it looks like to me. So, I'm trying to figure that out. Well, I hope it's not too much of a drain, but I'm going to try. I'm going to try to attempt to drive all of these LEDs on a single. I got one of these down. Try one. I think I was going to put start up here around to this one. Start here. Tricky. Try to make sure the arrows are all. So we're going to basically turn like, yeah, it's going to be tricky. Pretty tricky. Right. Will be okay.
cave little cove. Alright. So the arrows are going around this way. So we will have to Okay. Right. So need to stop ready. Okay.
May have been ignoring you, Twitch, so... Oh, nothing here.
Let's see. It's a little off, but OSD. Right. Now we're going to put the center one. Oh, where? Yes, yes. Well, I lost it for a second.
Whew. Wow. Rings a bell, these are curious. Children. And right, figure out how to apply this one. Ba, 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 ba.
So much like this dog. Oh, the camera's off. Yeah, you guys can't see it, but it's amazing. Right. I'll put on the next battery. Find it. Oh, guys, restoring his site now. Hey, back. Woo, look at this. So we now have a ring of LEDs. Now, the question is how are we going to use it? Hopefully we can use it right above the power. Hopefully we can power it. Right. I gotta do some soldering here. Make sure all the power is going where it needs to. Right. Okay, so we have this massive halo to power. Okay, I think we can move this out of the way. Works. We know it works. Okay, this part works. Okay. Spare LEDs. Spare chip.
this right now. Don't need the extra chips. Don't need these components right now. Need these bolts right now. Push it to the limit. Limit! Walk along the razor's edge. Speaking of which, need some music. Oh, that's not the one.
Hard to keep a straight face when I'm burning like fire, and you walk all the sides. I'm drawn in desire, and you have to think twice. It's hard to keep smiling when I try to set things straight. You don't.
Okay. I hate this case. It does not store leads nicely. I don't really want to deal with this right now. Go away. Alright, what have we got here? We actually got some power lines already, so we could solder them across. I think the good thing to do is to just get the inbuilt soldering wires across, and then we'll use the main leads to get where we need to go. I think that might be the best plan. Use what you got, right? So I know red is power, and I know red is power and white is ground. So yeah, I'm back. Oh, sorry I didn't reset early enough, but I was in the middle of the build and I couldn't reset the camera. But now you can see how this has all come together now. We've built a ring, a halo, and now we've got three rows of LEDs to play with. I'm thinking this is going to be like the brightest thing ever. And I hope that, it doesn't use too much power. I don't know how we're going to power this thing. I don't know if we can power it on a single USB, but we'll give it a shot. So, first of all, is we're going to power this across. I think I want to get rid of the shrink wrap. The shrink wrap is good. We'll see. Okay, just gonna cut some wires and then solder them to the other side. Strip these wires. Ugh. This is kind of tricky. Just need to balance this on my head. It's just the right length, but I probably will go for a longer length next time. Really don't want to snip it off. Okay, strip the wire. It's good. Now we're just going to solder it to the right place. Please don't fray. Just going to give it a bit of twist so it doesn't fray everywhere. Okay, I just want these contacts to have power, so that's why we're soldering it in a ring. Okay, just gonna have to balance this on my head and do the best we can. Alright, so here's the solder. I don't have a vise to hold this up. Just gotta balance it off my head. Ow, ow, hot, hot. Please don't burn my fingers. Please don't solder these together. Pretty sure that's ground. Pretty sure. I was doing this the wrong way. Man, that looks properly soldered on. Nice. Okay, that's power connected to one ring. I hope. Let's give it a test drive. Okay, let's give it a test drive. Okay, we got our circuit here. That goes there. Got a nice plug. Just need some leads. Alright, we're gonna try a test drive on the first ring, see if it lights up. How many is here? 1, 2, 3, 4, 5, 6, 7, 8, 10, 12. It's gotta be a fuck ton. How many lights are on here? We'll play it by ear. It's a lot of lights. Just gotta hook it up to the right places. Need a black lead, a red lead. Why does he need those? Those are the essentials. And a data link. It's got to be a green lead. Alright, let's give it a test drive. So we got our circuit here. Just need to put the leads in the right place. It's this one that's sticking out, so I have to connect this to my crotch. Data link goes in here. Black is white. Red is red. Huh. Okay. Wonder why that isn't going. There's just not enough power. What's going on? Okay, I've set this to 4. It's just not working. I'm gonna have to get my smaller strip back and see what's wrong. Okay, so this works. It doesn't that one. Hey! I don't know what happened, but it works. Got like a bit on this. You can't see. Oh, you can see that. You can see like the first little part working. You just gotta figure out like how far across it is. So I'm just gonna turn it up to. So that's 26. That's ending up around there. So I'm guessing 4 times as much. So we're gonna just do a flat 100. See if it goes all the way. Hey, it's a bit much though. So I'm gonna say 80. I need to know where the end of this is. So you can see like it's probably not a good angle from there. You can see the lights traveling across now. Ends around here. So 80, that's 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we got 93 pixels per ring. That is a lot of pixels. So we got like 2 lights like just rotating around. We're finally getting to the end game. Alright, I'm gonna put in, so there's 93 here, so I'm gonna put in like 10 pixel or 10 particles. So that'll be 10 rotating around at any time. Whoa! Look at that. Okay, so test drive, pretty good so far. Managed to get oh, the data connection's loose. Managed to get this flowing single direction. That is awesome. Okay, so we got the first ring of the Halo operational. Except that damn lead is so loose. Did it just break? Okay, I think I need to fix this onto here permanently. But how? I just need like a lead that goes into a resistor that goes into this. Yeah, I just want to set this up nicely over here. Okay. Ah! Maybe I could do it with header pins. Yeah, that's not going to pull off. I'll hold it steady for now. Got the first of the Halo rings up and running. Need to power the next set. Get the data lines working. Okay. I think I need another USB cable. If I can find one. Alright. Test over. Ring 1 works. I just gotta... How do I want to do this data? I think what I want to do is... connect to this data line to here. Or actually, I can reverse it and make the impossible happen. I think I need to reverse it. I think this ring we established is got to be like the first in line. Ah, cut the line. Or did I? Hmm. I could restrict a little more. Oh, God. Took the whole sleeve off. Okay. It's kind of secure. I have to put glue on this after. Okay, it's kinda disturbing. Might have to tear that one off and redo it. Looks too slapdash a job. Especially that I got a data cable coming in. That's super short. Yeah. Alright. Whoa. Okay, so we got the data cable. And we kind of tore off ground at the same time. Oh, we may have to do this again. That is an exposed wire. Okay. Get this data cable where we need it to go. Don't want anything more to touch that ground pin. So I'm thinking of just putting some glue on it. Be right back. Just
Two-way tape.
don't want anything touching that pin, the power pin. Time machine? Almost. Space machine. Infinite space. Hate the white. Am I overthinking this? I just don't want anything touching that palette. It's very unwieldy to solder together. As you can see, it keeps falling over. Having the time of my life here balancing this thing, especially when I need to hold multiple objects, like a hot soldering iron, soldering wire. It's fucking data pin everywhere. Fuck, I just ruined that. Okay. Alright, let's test this out. Let's test this out. Hopefully I didn't short circuit anything. Okay. Let's test. Alright, so with this new configuration, we should be able to get two rings lighting now. Note to self, strip wires a lot more generously. Okay, so we've got one ring going, so that's not short-circuited, so that's good. Alright, so the way this works is that it needs... So we've got 93... calculator off. Alright, so what's 93 times 2? 186. Let's try that. Now we should be able to see two rings light up. Doesn't look like it is. So, following thing here. Just wondering if it works. I think there might be a problem with the power. It's possibly the power. I'm gonna try powering it. Let's crimp these wires. Something's wrong with this. Not sure what it is. Might possibly just be a power issue. Okay, so it's just a power issue. Data line is fine, just needs power. Okay. I think this connected up properly. It's just a power issue. So once I have those connected to power, be gravy. Ah! Oh, right. I'm such a dumbass. So I wired the power across, but no wonder it wasn't getting powered. Because those aren't connected to anything. So I just got to siphon power off the main line. What's the point of building this? To learn electronics. That's the point. See how far we could push our knowledge. But so the theme of this assignment is art. So we're trying to fulfill some kind of artistic endeavor with electronics. Thank God. Okay, that's connected together. Not my best work, but it'll work. Just gotta do the same for the other side. I think I should probably move it physically further down the cord so it doesn't. It's a problem. Because I have to make it closer. I don't want the red and white wires to touch together. That would cause problems for the entire circuit. So if I make them physically apart, that means I could also seal it off with electrical tape, but we're not done yet, so just wait. Probably a poor way to do this. I'm committed now. Should probably just cut it all off while like twisting them together and then solder them. Where's the fun in doing things intelligently? So yeah, I'm just trying to splice these wires together. Okay. That'll do for now. Okay, spliced. Imagine it, Embo behind is playing in the background as he works. Lol. Okay. This may or may not work. think I cut the excess off, so this doesn't need anywhere. Okay, cut this off now. Okay, so we splice the wires together. This will give us power to the second ring. So, whoa, can't just stand up. That's a really poor quality black lead. Woo! So I've got 2 rings now. What if I had 20 particles? Yeah, it's because there's meant to be an LED here. That's why it's offset by a little bit. Hey! So we got 2. You can't see that properly. That's too bad. But now, if you look closely, we got two rings of LEDs now lighting up. Alright, just got to wire up the third one. Be good. Just gonna be lazy for this one. Okay. Spliced. Alright. Almost there. I may have wired this all wrong, but it's still salvageable regardless. No, it won't make a difference. But then it just doesn't make sense. Uh, Mm. Not my greatest work. I wired it all wrong. I'll just work on splicing this first, worrying about it after. End space, user smart, you make Papa proud. Thanks, man. Let's grab these ones. Nice. Okay. Spliced. Okay. Now I gotta figure out how to work this rat's nest of wires back to the front. Starter cable doesn't matter. This power plug is what needs to get to the back. So. Oh, we could cut off the excess stuff now. Alright. Power is wired. Let's go move that subtly to the front. Pack all the wires into that little crevice. Okay. I think I need some wires going across. First of all, I need a two-way tape, and then connect that data pin. Two-way tape. Oh, don't rest the ring on microcircuit. Oh. Leaning forward so much. That's it. Swear I was here. Oh, what's going on underneath the desk? Okay. Alright. Ugh. Okay. Technically, that should be powered. I hope it is. Looks like this ground could do some fixing as well. Okay. Let's try this out. Increasing. Wow, what the hell? Okay, so power is good, just the data line sucks. Okay, so we got 2 lines. We're going to power up the 3rd line. Um, 279. Uploading. Doesn't. Alright. I think I need to do some more fixing. I didn't splice the other end to the power yet. Okay, I just need like 2 wires. It should be easy. Almost there. Just gotta get this power connected. Woo! Alright. Hopefully that tackles the power. Okay. Let's test it out. Should cut those off. Alright. Hope it works now. Supplying power from both ends. Is that 3 lines? Hmm. I'm gonna measure the voltage. I don't know why it's not working. It's probably my dodgy wiring. We're actually getting power now, so I'm not sure why the data line is kind of shit. Oh, I see it. energy line. I'm not sure what's going on. Might have to take all the pins off and do it all again. Yeah. Had enough of this breadboard. Let's try to connect directly. Still doesn't like the third ring. Alright, 183 was the other, but can I get it? 183 was previous number, so I wonder if I could just continuously set it lower. It's still not passing this barrier. Wow, it just went off? Really? Loose connections. Still not liking this. Hope there's not a short circuit happening. I think I'm gonna have to do this wiring again. Just doesn't like this at all. It's not stable. I have to do it again. Yeah, I'm doing it again. It's just fucking bad. Thought I could pull it off, but I need to start again. Alright, let's try this again. Okay. Let's try this again. I'm gonna connect the data wires first. Makes the most sense. My wire's not turning out the way I'd like it to. Do some of this. Okay, I think I got the data line set up. I just need one main one coming out of here. Good to go. Alright, that's the first line done. Oh man, being so tired. That's a very weak wire. I'm not liking the look of that. I am once again, if I can put. I am once again, if I can put the mirror in my bathroom. Sure, that's a worthy goal to have. Not sure what you're trying to say there. You can probably put it in your bathroom. It's not a very difficult mirror to have. It's just wiring it up. That's the problem. I can't even wire it up. Mm. One down, several more to go. What's this? Oh, this is an infinity mirror. I had to like rewire the LEDs again, so it's not really working right now. But we'll get it there hopefully. Trying our hardest. So right now we're trying to fix the power cables. So we're doing like positive. So we got the data cables in. Um, got the data cables spliced in. We're just doing the red power cables now. My back hurts so much. Been like here a long time trying to get this working. Ugh, spilled molten solder all over myself. Ugh, jeez. Wiring is so boring. We had it half working before, but it went to shit, so we're starting over. Okay. Wow, that is a weak ass wire. So this is going to be an infinity mirror once we get it wired up. Been at this for hours. But we're getting there. Making progress. New wiring, I think, is a lot better. We're doing things properly. I thought I could hack it before, but have to do. Okay. Whew. Alright. So we did the data cables. And we just finished the power cables. So we just need the ground. And this is all wired up. Okay, I'm just trying to splice them all into one cable. It's a very tricky thing to do. Doesn't have to be so tricky, but I don't know why I get myself into these situations. It's like super ass weak wire I'm using here. So it's all tied up into a bunch. Just gotta solder it together. Good. Okay, so we got 3 power cables spliced together into the one cable. And then I just gotta splice it onto this. Always leave yourself more than you need. That's what I learned a lot today. You don't, you end up like splicing, not having enough cable to do anything. Alright, red power cable done. Now we just need the ground. Oh, back hurts so much from balancing this thing on top of my head. Thanks. Thanks for the silver. I'm gonna need it to fix my back. That's a lot better. Mm. Ugh, finally. Alright, so I did one relay of ground. Just wire that grounds leading out of there. Hmm. Hmm? Oh, hey. This is how I feel I'm building something without a manual. I didn't even start in what engineering language you're speaking, but okay. Sorry, I haven't been speaking. Are you still there, Zarity? I can answer some questions. I was like in deep focus. Deep focus. Like the deepest of focus. I was just talking about like just general just general oh, almost there. I was talking about just general. I was just talking about like electrical engineering. Um, so just some basic circuitry concepts. It's not that hard. Anyone can learn it. What will this tool do? I don't know. What do you mean tool? Who are you calling a tool? So this isn't a tool. This is going to be like just something cool to look at. It's going to be some arts projects, believe it or not. Shouldn't have to breathe in these fumes. Okay, we're on the final. We're in the final lap. Ugh. The Infinity Mirror. What's it for? Art. Yeah, it's art. It's just art. But we're very close to finishing the wiring at least. So this is why I hate being hardware. Software is so much easier. Just got to wire everything right. It's pretty much akin to doing surgery. But no one dies. No one dies in this. I've been balancing this on my head for a long time. Can't wait to get it off. Just deep focus. I haven't even eaten dinner yet, but I just want this done. think that's done. Woo! Okay. Alright. Just gotta splice up the final ground wires. Almost done. Okay. So we wired up this whole thing and didn't do any testing. So, hope it was worth it. Okay. So attach that to this and on the home stretch. Oh, wow. Okay, I think we did it. If there are no issues, this will work. If not, I might have to call it a day. I think I'll put a bit more soldering on there. Okay. Cut this. Oh, okay. I'm gonna cry if this does not work. Like, seriously, like, just so much work has gone into, like, making this work again. Okay. Right. kind of works, but I'm not sure why it doesn't. Alright, let's see. Just gonna flash the program one more time. Is there a better lead? It's only got 2. So we got 2 bands going. Not sure why the 3rd band isn't going. Maybe the signal can't reach. Maybe it's just too far. Or is the 3rd set of LEDs broken? I need to see. Hmm. I don't know what's wrong with the 3rd one. I've got 2 rings working, but third one just doesn't want to work. Not sure. Seems like the third ring doesn't want to work. I don't see anything wrong with it. This thing's annoying me. Why does it keep stopping? And I thought it was done with the this BS. I can only get 2 rings up and running. If that's the case, like, I don't think I just got to tear out the middle ring. There's nothing. I've tried rewiring it, just can't get the third ring going. I'm not sure why. Can only get 2. Is it just a broken terminal? Power getting there, but I'm not sure why there's no data signal getting there. Okay. I think we just gotta cut our losses. Just gonna have to have just 2 rings. Can't do anything about that. Okay. Find pin for. I think it was like 27.9. Yep, the 3rd ring still doesn't light up. Yeah, I'm gonna cut my losses. Spend too much time on that. Alright, so the plan is now is like we're just gonna cut out the 3rd ring and just try and reposition the LEDs properly. We know that the first 2 LEDs work, so it's as far as we can take it. So that's fine, whatever. I guess 2 rings is better than 1, and ugh. It's already 9. What am I using to drive the LEDs? There's this thing called a Moteino. Moteino. So that is that's basically an Arduino, but it's smaller. It's not bad. I know, right? Like, this is what happens when you don't test, but this is the exact same result I got last time with worse, like, wiring, and it's not going. So, I think I've reached the limits on how many LEDs I can wire together. I think the signal's just not traveling very far. It's either that or, like, I don't know, like, the digital out of one of the rings might be broken on line 2. So, it's a shame we can't get that working. And it's just not enough time. So like you can see what's happening here. So we got two rings lighting up, but the 3rd one isn't. So the plan is, screw it, I'm just gonna have 2. I'm going to like strip out the 3rd one because I know the first 2 work, and then we'll try and reposition it. I think that's the plan. You can go back and test each circuit, right, if it doesn't work. No, like this is all one circuit. So the LED lights. So so basically the furthermost ring of LEDs, that's like the first, and then it spirals upwards into the second. So it's actually one really long LED strip. But the problem is we can't get the second LED strip to connect to the 3rd one, and I'm not sure why. But it's, I don't know, like if I want to spend more time like fixing that. I mean the second LED strip, the connection on the end might be just crappy, but it's nothing. Wasting too much time. It's kind of due in 3 hours. This project. Oh, sorry. I just realized that when I have that I'm in a meeting and have the speakers on mute. By the way, I'm loving your desk. Thanks. We're trying to get this portal working. I don't know this up free though. Okay. Alright. Just gonna have to strip this out. I thought I did well, but apparently not well enough. Okay. Alright, so we're just gonna remove the third strip. That's fine. To be honest, I didn't know how far I could take this strip, but I thought I could get all three, but I couldn't. Might be just the digital driver signal not going. Not this time. Now we just got to work on relocating these rings. I really wanted 3 rings, but maybe there's just something I'm not understanding. Like, I thought I could wire all of these together, but at some point, I don't know, it just stopped, it just loses the signal. So, I think for the time being, we'll just shift the ring placement down. If this, if shifting it down like 1 centimeter, if this breaks this ring, I'm gonna cry. I'm just gonna give up and go home. Like, yeah. I'm just saying, if this it's not aligned, it's like slightly out. Okay, test it. Hopefully it still works. Still works. Great. Okay. Relocation complete. Please still work. Nice. Oh, we had 30 particles in there. I'm gonna glue that in. Okay, I'm gonna permanently glue it in. Just want to test it, do it whilst we're testing, so if anything goes wrong. The battery's gone. Might not be able to keep up stream for much longer, guys, so I'm going to have to turn it off. Thanks for tuning in. I'm glad you could see me get it this far. Okay, the ring's finished. Had to make some cut. Had to cut some corners. All in all, it's finished. Mm-mm. weird. Just killed itself. Alright, now to get this working with a wireless transmitter. I like that wristband photo. A lot of people do. I generally try to keep it on because when I'm in the space, can't look at the PC all the time. So it's good to have like the chat on my wrist. So no matter where I am in the space, I can just keep situational awareness and everything. Okay. Whew. This is finally sorted. Everything there is happy. It's reliable somewhat. I have to just permanently solder that down eventually. We're still developing it, so now we need to bring the other Arduino into play. Oh, that was a very cheap case. Alright. Now, we now have to deal with this. See about this back cable. Might not be able to continue. Okay. Ugh. Alright, got it working, so it's doing its own thing. Now we need to figure out how it's talking to this wirelessly. Is there a reason why it's not working? Weird. And it's strange. Try the other. Okay. Alright. 69H.
drink too much. I tell myself that I can't stop. We could see clearly now. 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 We could see clearly
USB cable. Gonna have to go back to the basics.